Dave's Think Tank. Over the years I've had a lot of difficult problems to solve on these pinball machines. These older machines come with a set of built-in tests which are okay at what they do, but they really can't help you diagnose more difficult issues. For example, I had a problem on the flash cord. Every once in a while, when the ball was shot into the shooter lane, the machine would automatically score 10,000 points. Not always, not very often, and never reproducible. Really frustrating. So, where was the test for something like that? While I was rewriting the flash Gordon with the Arduino, it occurred to me I could also rewrite the tests. I could add any test, change up any test, do whatever I needed. So I wrote my new tests, cleared up a lot of issues, and then I thought, wouldn't it be nice to have an Arduino on all of my machines so I could solve problems like these on all of them? And then I realized I could easily do that. I could write a program that just does the tests without the game. Download it to the Arduino, move it to my other machines, test them, put the Arduino back in the flash Gordon, and replace the flash Gordon game software. In fact, anyone with an Arduino on any of their pinball machines can follow these steps to test all of their machines. Let's give it a try. This is my setup for the flash Gordon. The Arduino fits up here on J5 of the MPU. The cable comes out the back so I can reprogram without even opening the back box. I can plug it into my laptop. Ignore the lights that come on. And I've got the pinball test software downloaded here. Download it. To the flash Gordon. And it's all set to test this pinball machine. Now what I've done here, I've turned my flash Gordon into a self-testing machine that knows nothing about playing pinball. I'm going to unplug it, turn out the lights. It knows nothing about playing pinball. It will never play pinball again unless you have the game software. Software for most games can be found available on the internet for free, but just make sure you have that software before you do this. So what I can do now, I can run the tests on this machine, and then move the Arduino to the next pinball, test it, move it again to another pinball. Any pinball, Bally or Stern with this type of original or replacement MPU board can be tested. Then put the Arduino back in the original machine, and I will load up the software for the game. Plug it in. And upload the game software. So the flash Gordon game software is now safely reinstalled. Like I said, make sure you can replace your pinball's game software before doing any of this. So let's reload the pinball test unit software and try it out in a different game. So here's the Arduino installed in my Bally Star Trek. It has an Alltek board, so it installs easily. Just remember, on some older boards you may need to use one of these cables. Now when you start the pinball, should see the version number 2001-01. I chose that number because it sounds really futuristic. If you don't see that version number, there may be a problem. Either the software didn't load properly, or the Arduino isn't installed or set up properly. Now, there are several screens you need to go through before you can run the tests. The pinball test unit needs to know about things in your machine, such as how many digits are there in the displays, how many solenoids do you have. Let's run through these steps really quickly because it's really fairly simple and it's all in the manual. You get a manual when you download the software. You can save the data for up to 100 pinball machines. Just select a number from 0 to 99. The next step, we can tell it how many digits there are in the displays. There's 6 here, 6 here. How many lights do you have? How many solenoids do you have? How many switches are on the machine? How many sounds can it make? Which of a number of sound cards do you have? And this is interesting. You have to select, this is going to run through all of the solenoids, and when you get to the ones that you want to reset during later tests, you let it know. So I'm going to say, there's a bunch of blank ones here. We don't need any of these. Don't need that. Don't need that. No. But we do want to reset the drop targets. Okay, and we're back to our first screen. We can start our tests. This is the first test, the light test. It probably looks familiar because so far it's exactly the same as the standard light test. Until you press the button. Now the test will go through every light individually. So why would you want this? Well, maybe you just find it easier to work on a light when the whole machine isn't blinking at you. In some machines, these light switches control not just the lights, but also switched relays, and it can be important to find them. You can also make up a numbered list of lights, making it easier to locate problems in the future. A numbered list is essential if you want to do any Arduino programming of your own. There are lots of advantages to expanding this test. The second test is the display test. The first difference you'll probably notice is it's a lot faster than the standard display test. Every digit gets through the numbers from 0 to 9 in 2.5 seconds instead of what used to seem like 2.5 minutes. Trying to watch 5 displays of 6 or 7 digits, each taking 10 seconds to complete, was always a tedious process. To make it easier though, you can, again, press a button. And now you can watch 1 digit at a time going through its paces without distraction.
Charlie, activate tractor beam.
Hold in the switch. And you can scroll to the digit you're interested in. And scroll to the end and all the digits are displayed again. And yes, I do have 1 digit out. The third test is the solenoid test, and there are some major improvements here. The usual solenoid test goes through all the solenoids one by one, making this lovely racket the whole time. Except usually you're interested in testing a single solenoid, and not all of them. Wouldn't it be nice if you could just stop the solenoid on the solenoid you want, just watch it fire, just by pressing the button. Or I could just push another button. Oh. This stops the solenoid. I can make an adjustment, and I can press the button again to see if my fix works. I can stop it, start it up again, stop it, move on to the next solenoid, whatever I need to do. But there's more. Suppose the switch is activated. Let's turn that off. Now every time a switch is activated, the switch number is shown in the credit display, and the time between the last solenoid firing and the switch activating is shown in player 2. So why do you want this? Sometimes a switch will develop a sensitivity to vibrations from a solenoid. The solenoid fires, the vibration activates the switch, and you get 10,000 points out of nowhere. Let's watch it one more time. If that was activated by vibration instead of by hand, you'd have some useful information about how to fix your pinball machine. So this is how I found that problem I mentioned earlier, where I sometimes scored 10,000 points on a new ball. The first thing a pinball does on a new ball is reset all the drop targets. The vibration from resetting all of the drop targets would cause the third inline drop target to register its switch, but only if it started in the down position. So you had to have dropped all 3 inline targets in the previous ball.
Try the wood beast or die.
But not having hit the wood beast to reset all the targets. And that's why it happened so randomly and wasn't repeatable. But now there's a test to find these issues. Test number 4 is the stuck switch test. It works like the old test in that any closed switch will be displayed in player 1. But it improves on the old test by displaying up to 4 switches. In the 4 displays. And if there are more than 4, there we go. If there's more than 4, the credit display gives you a count of the stuck switches. And in addition, if you're testing drop target switches and need to set them again, just double click the button. That's a lot easier than prying the targets up or lifting the play field to raise them by hand. This is mostly meant for drop targets, but you can set it to activate any solenoids you need to kick a ball out of a hard to reach place. Test number 5 is an all-new test that you can use to detect switch bounce, which is the term used for a switch that registers double hits. To do so, activate any switch with a pinball, and the switch number will show up in player 1. If it happens to be a switch that produces a double hit or a bounce, like this one's going to, hopefully, there we go. Switch 18 registered twice. I should do something about that. Probably have to clean it or regap it or maybe even replace it. It's a good idea to go around the playfield, activate all the switches with a pinball to see if any have an issue.
Captain, pull ahead. Walk back at 1.
Test number 6 is the sound test. The original test simply played one sound over and over. The new test goes through all the sounds in the machine.
Arm photon torpedoes.
Press the button to stay on one sound.
Arm photon torpedoes. Arm photon torpedoes.
Playing it repeatedly. Or hold it in to scroll through the sounds quickly.
Photon torpedoes, fire!
We may be here for a very long time, Doc.
Now, I just want to mention a couple of issues with the sound test. It currently only works with the original Bally Squawk and Talk boards or replacements like the GTO boards or a wave trigger sound board. In particular, it doesn't work in machines with the very early Bally sound modules or their GTO replacements like this Star Trek. These early boards did not play sounds on demand. My understanding is they sort of monitored your game and played sounds when something happened, like a pop bumper going off or something like that. That's just not possible for me to recreate in a general purpose test unit, so for the purpose of this demonstration on this machine, I installed a wave trigger board. Test number 7 is an all-new dip switch test. This allows you to check the values of all 32 dip switches. Now, the test is slightly different depending on whether your game has 6-digit or 7-digit displays. Your game has 4 banks of 8 dip switches, which can't be displayed in either 6 or 7 digits. If you have 7 digits, the 8th switch of each bank is displayed in one of the 4 credit or ball in play displays, for a total of 32 switches. If you have 6 digits, then it's simply not possible to display all 32 dip switch values at once. So the first 6 dip switches are displayed for each bank, and the last 2 for the current bank are displayed in the credit window. So here we have dip switches 1, 2, 3, 4, 5, 6, 7, and 8. Scroll through all the dip switches to bank 2, and the credit window is updated with the final 2 dip switches for bank 2. So 9, 10, 11, 12, 13, 14, 15, and 16. So scroll through all of those, you get to the third bank, and here are its final 2 switches, and the same for bank 4. Switches 31, 32. The Pinball test unit software is available for free on GitHub. I'll leave a link in the description below. The complete manual is included and covers everything we talked about here in much greater detail. If you have any questions on uploading the program or running the tests, you can refer to it. And if you have any ideas for tests you'd like to see added to the list, let me know down in the comments. But for now, let's play a game. That's a nice first ball. Let's see if I can get the... no, can't do it. Not going to do it today. skill shot. Let's go for the skill shot. 15,000. Flash loves to go right down the center. Again.
Escape is impossible. Escape is impossible. Oh, Flash. Escape is impossible.
Some player shoots again. Okay, skill shot, come on. Yeah, 15,000. See if I get that 4 times. Yeah, 800,000. Not a terrible game.